of natural phenomena, based on empirical evidence from observation and experimentation. Mechanisms such as peer review and reproducibility of findings are used to try to ensure the validity of scientific advances. Natural science can be divided into two main branches, life science and physical science. Life science is alternatively known as biology. Physical science is subdivided into physics, astronomy, earth science, and chemistry. These branches of natural science may be further divided into more specialized branches, also known as fields. As empirical sciences, natural sciences use tools from the formal sciences, such as mathematics and logic, converting information about nature into measurements that can be explained as clear statements of the laws of nature. Modern natural science succeeded more classical approaches to natural philosophy. Galileo Galilei, Johannes Kepler, René Descartes, Francis Bacon, and Isaac Newton debated the benefits of a more mathematical as against a more experimental method in investigating nature. Still, philosophical perspectives, conjectures, and presuppositions, often overlooked, remain necessary in natural science. Systematic data collection, including discovery science, succeeded natural history, which emerged in the 16th century by describing and classifying plants, animals, minerals, and so on. Today, natural history suggests observational descriptions aimed at popular audiences. Creating knowledge and understanding through science equips us to find solutions to today's acute economic, social, and environmental challenges and to achieving sustainable development and greener societies. As no one country can achieve sustainable development alone, international scientific cooperation contributes, not only to scientific knowledge but also to building peace. Unlike other types of science, such as physics or chemistry, natural science comprises multiple disciplines with the ultimate goal to better understand how the world around us works and functions. Often, natural science is confused with other types of science and concepts. But why is this the case? For starters, the term is poorly translated between countries, causing further misunderstanding. Second, the word natural contains various meanings, allowing others to interpret it individually. With so much confusion, it's no surprise that only a few people know what natural science actually is, and that's usually those either studying the discipline or who work in a similar role already. But with the confusing part out of the way, the remainder of this article will explain more on the concept, including more info on the different branches, how it's different from chemistry, and some real-life examples. Within natural science, there are 5 branches. These are as follows: astronomy, biology, chemistry, physics, earth sciences. Each of these individual disciplines works together to better understand and seek explanations for the rules of the world, essentially how everything works. The better we understand the natural world, the greater change we can create, the more innovative we can be, and the faster pace we can live thanks to new developments. Astronomy is the study of space and the physical universe, with a focus on planets, galaxies, stars, moons, and comets. Basically, it's everything away from Earth, with a lot of objects we can't see with the naked eye. Biology. You're likely a little more familiar with biology than astronomy. However, if you're unsure, biology is the study of human life. This can include plants and animals, the human body, and other living organisms. Chemistry looks at different elements and how they react with one another. There are multiple branches too, including nuclear, biophysical, and environmental chemistry. Chemistry often complements physics and other sciences, helping us better understand concepts such as gravity and mass. Physics helps us understand how the universe behaves, focusing on concepts such as gravity, heat, light, sound, and radiation. As part of natural science, physics is fundamental. Earth sciences. Often, many people confuse the single discipline of earth science with natural chemistry. However, they are quite different. For example, earth sciences focus specifically on the planet Earth. The more we know about earth sciences, the more we can evolve, learn from past mistakes, and create a better future for all. How is natural science different to chemistry? Chemistry is the study of properties, how they interact with one another, and the various changes substances undergo. Natural science, on the other hand, contains multiple branches, of which one is chemistry. Therefore, natural sciences uses chemistry to complement other branches to make better sense of the world around us, as opposed to understanding a singular concept or natural reaction. There are many examples of natural science, however, one relatively popular one is climate change. For instance, the different branches complement one another to help us better understand the consequences, how to prevent further destruction, and even reach beyond that, plans to leave the planet and colonize another, such as Mars. While it may seem a long stretch, other scientists would work closely with those focused on the natural world. There are many examples of natural science, however, one relatively popular one is climate change. For instance, the different branches complement one another to help us better understand the consequences, how to prevent further destruction, and even reach beyond that, plans to leave the planet and colonize another, such as Mars. While it may seem a long stretch, other scientists would work closely with those focused on the natural world. If you've ever asked yourself how animals survive in the wild, what fuels a rocket launch, or why some chemicals react explosively while others don't, you're already on the path of a natural scientist. Natural sciences focus on applying scientific methods through hands-on experiments, observations, and data analysis. They focus on discovering the laws and patterns that explain how the universe and everything within it functions, from the smallest particles to the largest ecosystems. By studying areas like ecosystems in biology, chemical reactions in chemistry, and the law of physics, students gain a clear and practical understanding of how the natural world operates. This approach encourages curiosity and critical thinking, and prepares them to tackle some of the world's most pressing issues, from climate change to medical breakthroughs. The distinctions between the natural science disciplines are not always sharp, and they share many cross-discipline fields. Physics plays a significant role in the other natural sciences, as represented by astrophysics, geophysics, chemical physics, and biophysics. Likewise, chemistry is represented by such fields as biochemistry, physical chemistry, geochemistry, and astrochemistry. A particular example of a scientific discipline that draws upon multiple natural sciences is environmental science. This field studies the interactions of physical, chemical, geological, and biological components of the environment, with particular regard to the effect of human activities and the impact on biodiversity and sustainability. This science also draws upon expertise from other fields, such as economics, law, and social sciences. A comparable discipline is oceanography, as it draws upon a similar breadth of scientific disciplines. Oceanography is subcategorized into more specialized cross-disciplines, such as physical oceanography and marine biology. As the marine ecosystem is vast and diverse, marine biology is further divided into many subfields, including specializations in particular species. There is also a subset of cross-disciplinary fields with strong currents that run counter to specialization by the nature of the problems they address. Put another way, in some fields of integrative application, specialists in more than one field are a key part of most scientific discourse. Such integrative fields, for example, include nanoscience, astrobiology, and complex system informatics. The natural sciences are dedicated to the systematic exploration and understanding of the physical world and the laws that govern it. This area of knowledge encompasses disciplines like physics, chemistry, biology, and astronomy, that all seek to uncover the mysteries of the natural universe. Certainty plays a central role in the natural sciences, as they seek to establish empirical and predictable patterns in the physical world. Explanation involves deciphering the underlying principles and mechanisms that govern natural phenomena. The concept of objectivity emphasizes the importance of unbiased observation and impartial analysis in the pursuit of scientific knowledge. Two influential thinkers in the natural sciences from diverse backgrounds are Marie Curie and Albert Einstein. Marie Curie, a Polish-born physicist and chemist, made groundbreaking contributions to the study of radioactivity and was the first woman to win a Nobel Prize. Albert Einstein, a German-born physicist, revolutionized our understanding of space, time, and the universe through his theory of relativity. Contemporary issues in the natural sciences often revolve around ethical considerations and the responsible use of scientific advancements. Discussions about genetic engineering and CRISPR technology raise questions about the ethical boundaries of manipulating the genetic code and the potential consequences for future generations. Additionally, the exploration of climate change and sustainability underscores the need for scientific solutions to address urgent global environmental challenges. Natural science is more complicated than it may seem, made up of 5 individual disciplines that complement one another so that we can better understand the world around us, not only on planet Earth, but the entire solar system. Thank you for watching this video.